Hey everyone, and welcome to the Organic Chemverse. This channel is all about helping you succeed in your organic chemistry courses. I'm here to answer your questions and walk you through challenging problems. Now, let's solve today's challenge. There is a molecule with the molecular formula C₃H₆O, which upon hydrolysis, acidic hydrolysis, it gives two products, say product 1 and product 2. We don't know what are the products. We need to identify the correct statements from the given options about the reactant and the products. Without the help of the options, we can't solve this. So let's read out the options. The reactant A can give addition product with HCN. One of the isomer of A is optically active. Both products react with Grignard reagent. One of the product gives positive iodoform test. Before we start solving the question, first let's identify what is the degree of unsaturation for the given molecule. What is degree of unsaturation? It tells you whether the given molecule is having a double bond or not, or does it have a cyclic structure. So we can predict that. What is the formula? 2C plus 2 minus H by 2. If you need more information on degree of unsaturation, I am giving you the link for this. You can just go through the video. It's very helpful, especially for competitive exams. Now, 2C plus 2 minus H by 2, we are not taking oxygen. Oxygen is considered as 0, where C is the number of carbon, H is the number of hydrogen. Let's substitute the values. So 2 multiplied by 3 would be 6 plus 2 minus how many hydrogens? 6 are there, divided by 2. So upon solving, we get 1. So if the degree of unsaturation is 1, that means there has to be one pi bond or one ring. Right? So we write ring like this, either one pi bond or a ring. Now, what are the possible structures? We need to write, otherwise we can't answer this question. So there are 3 carbons. So CH3CH2COH, it's an aldehyde, or it can be even a ketone. Ketone is a functional isomer of the aldehyde, or it can be a pi bond because it says pi bond, right? So then we have an oxygen and methyl. So because it's an ether. So why did I write ether? Because it says acidic hydrolysis, right? So we know ethers easily undergo acidic hydrolysis, but not the aldehyde and ketone. So maybe this can be the reactant. Now what are the other possibilities? We can write a cyclic structure like this also, right? So these are some of the possible structures we have written for C₃H₆O. So double bond, pi bond, pi bond, pi bond, and cyclic structures. Okay. Now, the first statement here in the question is the molecule undergo acidic hydrolysis. So as I was telling earlier, these two will not undergo, right? This can undergo, and also it says that it forms 2 products. Let's check for this particular molecule. Can it undergo acidic hydrolysis? Right? So when we do acidic hydrolysis, so we know that the first thing is it undergo protonation, right? And then oxygen is having positive charge, so this is not stable. So it will undergo reaction with water, and we are going to get enol, and this is a methyl. Therefore, what will be the other product? Methanol. And this is enol, and we know enols are not stable. It will undergo tautomerization like this. So how do you write this? We write it like this: CH3COH. It's enol. There are 2 carbons, 1 2 1 2. So it's nothing but ethanol molecule. Okay, so this is the only one which is giving 2 products. So this might be our reactant, right? Let's check the statements given here. The reactant A can give addition product with HCN. No, this will not undergo reaction with HCN. But whereas aldehyde and ketone do undergo, but this is not a right statement. So this is not the one. Remember students, we might have more than one right statement, so we can just have to check for all the other statements. So one of the isomer of A is optically active. So assuming this is our A, does it have any optically active molecule? Not this, but this does have a chiral carbon. Look at this. We have methyl, we have oxygen, we have a carbon, and of course there is a fourth atom, that is hydrogen. Yes, this is a true statement. Correct statement is B also. Okay. Now let's check for C. Both the products react with Grignard reagent. So both, so they are telling two products. Say, what are the two products we got? One is ethanol, acetaldehyde. Does it react with Grignard? Yes. What is the reaction here? So I'll take in general, right? Like we can take specific also, methyl magnesium chloride, no problem. You can take either one of them. It undergo addition reaction, right? So you're going to get OMgX, and what about here? R and H. Sorry, this is C. Okay. Yeah, it will undergo. What about methanol? Does methanol undergo reaction with the Grignard? Yes. Here it is acting as a nucleophile, but here it will act as a base because we have a acidic proton. So R minus will abstract the proton. It becomes a hydrocarbon, and this will be a salt of magnesium halide, right? Yes, this is also correct. The statement C is also correct. Both the products react with Grignard reagent. One of the products undergo addition, the other one undergo the acid base neutralization kind of reaction. Now, one of the products gives positive iodoform reaction. So the products are ethanol and methanol. Let's check now. Ethanol does undergo iodoform reaction. So what is iodoform reaction? You know that whenever we have a methyl carbonyl compound, right? The carbonyl can be aldehyde ketone. When it is treated with, say, here they are saying iodoform. So I'll take iodine only. Iodine and NaOH. Then what happens? The methyl which is attached to carbonyl will form iodoform, which is a yellow precipitate. What is the fate of this? It will undergo complete oxidation like this. So this is forming iodoform. Methanol will not undergo reaction, but ethanol, acetaldehyde do undergo reaction, and it gives positive iodoform. Why positive iodoform? It is going to form a yellow precipitate due to the methyl group. Therefore, this statement is also correct. So among the given options, option B, C, D are correct for the given molecule. So what is reactant here? The reactant is an ether, right? It's a methyl vinyl ether, and this upon hydrolysis it's forming ethanol and methanol. Those are the products, and the statement B, C, D are correct for the reactant and products. I hope this question is crystal clear to you now, and as usual, if you have any question or doubts, you can ask me in the comment section. Thank you for watching this video. Until next time.